Hi guys, this is Math 148, section 12.5, and this section is all about differential equations, or as the cool kids say, Diffie-Q. So you could imagine being an engineer and you could take an entire semester long class, Diffie-Q. Oh no, I'm in 8 o'clock Diffie-Q with Henderson. So this section 12.5 is just an introduction to a much longer topic of how to solve differential equations. And it might seem like it's off of what we've been doing, but it's actually exactly the same thing that we've been doing with integrals. So suppose I told you that you had the derivative of some function y is equal to 3x squared, and I said, what is y? Solve for y. That's a differential equation, by the way. What is y? It's exactly what we've been doing in the other sections of chapter 12. Essentially, we're saying, well, I can take the integral of this derivative, so that's the integral of 3x squared, which is equal to 3. Take the constant out in front. You add 1. Integrals add 1. So that's x cubed. And then 1 over 3. So the 3's cancel. That's x cubed. And on this side, you say, well, whenever I take the derivative, or the integral of the derivative, I just get the function back. That's how it goes with integrals. You take the derivative, take the integral, you're back to the function. So we're saying y equals x cubed plus some constant. So this is exactly what we're doing with these differential equations. Let's look at an example. So here is question number 1 in your textbook. And flipping paper. Question number 1 is on page... Sorry, I got a little excited. 788 in the 10th edition textbook. So question number 1 says, show that this function, y equals x squared, show that this is a solution. Show that this is a solution. I'm writing it out just so you can understand what the goal of the problem is. That this is a solution to the following problem. We also have this, 4y minus 2x y prime equals 0. So we have this equation, y equals x squared, and we have this equation over here. This is a differential equation because it has a derivative in it, 4y minus 2xy squared. This piece over here is the Diffie-Q. Your brain gets into a blizzard at the Diffie-Q. Show that this is a solution. So this is what you do. To show this, let's take the derivative of this side, y prime. So the derivative of y is 2x. Remember, you don't add a constant. There's no constant because you're taking the derivative. Okay, so now let's try plugging this in to see what we get. We get 4y, oh, excuse me, 4. We're going to plug y is now x squared. 4 times x squared, do you see? The y is x squared, minus 2 times x. I'm solving in terms of x because there's this x here. I can't just leave it all in terms of y. Y prime now is 2x. So this equals 4x squared minus, 4x squared. What does that equal to? 0. Check. So this is how we showed that this is a solution. So our step was, the steps to doing these problems was take derivative of y and then plug in and set the Diffie-Q, the differential equation, in terms of x only, and then solve. In terms of x, and then solve. Let's do another one, shall we? Yes. I would say, I'll let you do this one. I'll just sit here and let you watch a blank piece of paper while you do this one. No, it's question number 2. So this one's not on your homework. We have y equals x cubed. And the Diffie-Q is 3y minus x, y prime equals 0. And again, we are trying to show that this answer, y equals x cubed, is a solution for this differential equation, is a solution for that. So here's a solution. We're saying, is this a solution? Well, let's follow our steps that we did before. Take the derivative of y, 3x squared, no cookie because it's the derivative, not an integral. And now we're going to plug it into this and get this equation in terms of in terms of x only. So we have 3 times, for y, we're plugging in this, x cubed, minus x, the x gets to stay, times y prime, which is 3x squared. What does this equal? We can't just say equals 0 because we're testing. Does it? Does it equal 0? 3x cubed minus 3x cubed. Yes, that equals 0. And the reason we want to write this whole equation in terms of x is because there's no differential equation for x. So once it's in terms of x, we can just solve it. But this y prime thing, we want to get rid of those to solve them. It's easiest if we can show that. So that's how to do those problems. Now I'm going to show you another type of problem. This is question number 5. Find the general solution. General solution. So find the general solution, and they're going to give you a differential equation. General solution. So before, in the previous problems, if I show you here, like this one, they said, prove that this is a solution. And in this case, now they're going to say you have to come up with your own solution. So question 5, we have dy, the derivative in terms of y, equals x e to the x squared plus 1 dx. Now were I editing this textbook, I wouldn't have started with this one. It's a little complicated. So here's the problem. We have this dy here on this side. And we don't want a dy. We want this to just be a y. So what you can do is you can actually just take the integral of both sides. So in my mind it's similar. You know, if I had x squared equals 25, you can just take the square root of both sides. Okay, we're not taking the square root, but you can take the integral of both sides, and it maintains the balance of the equation. So do that. So you want dy by itself. It's all by itself. So we take the integral of both sides. So the integral of dy is just y. Why is it y? Because this is 1. So you have like 1 times dy, and the derivative, or the integral of that is y. Again, you could think of it as y to the 0, and you add 1, so it's y to the 1. Okay. This side's going to be a little bit trickier because they gave us a slightly more complicated derivative. I'm going to go through the u substitution. So I don't like this complicated function in the exponent, so I let u equal x squared plus 1 du, the derivative of u is 2x dx. I wish there was a 2 here. If there was a 2 here, my life would be perfect. My house would be clean. My dogs would be well groomed, but there's not a 2 here. So I'm going to add a 2, but I can only do that if I divide by 2. So if you put a 2 in there, you have to divide by 2. So this becomes the integral of 2x e to the x squared plus 1 dx. I was just rewriting it. So now this piece becomes the derivative of u, and this one's e to the u. This, I believe, was section 12.3, but I get the sections a little confused. So the answer, I'm leaving the y side for now, because that side's done. That side's done. So this is 1/2 e to the u, because that was the perfect integral, e to the u times the derivative. We get some constant plus our cookie, but now we want to write it back in terms of x. You can't just leave a u in there. You can't say y equals something to the u. You have to solve it in terms of x, people. E to the x squared plus 1. And you might say, did y get a cookie? Yes, plus a constant here, plus a constant here. So you have y plus some constant equals 1/2 e to the x squared plus 1 plus some constant. So we're almost done, but I'm going to show you one tricky thing about these constants. So we had y plus a constant equals 1/2 e to the x squared plus 1 plus a constant. And the way you deal with these constants is you just add them all together. So we don't know what this number, this constant is. It's just some number. We don't know what this number is. It's a different number. So we don't necessarily care what the number is. So we can just add them together and make it a new constant. So this is what you do. You just say plus a constant. So when you're done, you just put the constants together in one constant. It's just sort of the general one constant, the general formatting assumption that we've all decided on in the mathematical world. I think of it like this. This is y plus some change equals 1/2 e to the x squared plus 1 plus some change. So you get y equals this, and this is just all thrown into the change jar. So you don't necessarily care how many pennies they were. It's all just going into change. Now that's obviously not a mathematical definition. The answer is this is some number, this is some other whole number. When you add them together, you get some other whole number, and you can just leave it like this. So this is the answer your book is going to give you, and the reason there's only one constant is because they added them together. Okay, I'm going to do one more on this video, and then I will do a few more on another video. Question 8. You have 4. So again, trying to find the general solution. 4y dy equals 4x cubed dx. So when you're just looking at this problem and it says find a solution, right? The question says find a solution. Typically find a solution means you want y equals something. But you see these dy and dx over here? That tells you that in order to find the solution, you have to take the integral, because these should tip you off that in order to get rid of them, you have to integrate. So the good news is we have y's on one side, right? It's like shirts and skins, right? We have y's and x's, 2 different teams, and that's good. So we have y on this side, x on this side. We're going to take the integral, so we did the first time before. So the integral of this side is now the 4, the constant comes out in front. This is y squared, and then 1 over 2, right? Because you add 1, y squared, 1 over, plus some constant. On this side, it's the 4 comes out in front. X, add 1 to the 4th, and then take 1 over 4. This is section 12.1, plus some change, constant. So this becomes 2y squared plus a constant equals x to the 4th plus some constant. And the answer, this is how you leave these problems, is 2y squared, remember the constants, they just go together, some new constant, equals x to the 4th plus some other constant. We don't care what it is. So you can leave it like this. This is the other piece of this that is not intuitive. You are done here. You don't actually have to solve for y. You don't have to say y equals plus or minus square root of blah, 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 blah. You don't have to do it. Just leave it. That's fine for now. Okay? So try these problems. I'm going to do one more video with a few more of these because they're so fun.